My name is Jamika. Some of you have seen me before. Some of you, nice to meet you. I'm a partner engineer on the developer support team, and we will be talking about, or I'll be going over kind of an overview on maps and how do we actually use them in Studio. So I think the next slide, Pablo, I'll take control soon, but we're gonna make Pablo work harder just a little bit longer. So what is Niantic Maps for Web? Next slide. Just as an overview, if you joined our if you joined our session last week with Owen, he went into a lot of detail about what is Niantic Maps for Web and kind of the nitty-gritty details. So I'm only going to do kind of an overview of that. If you want to learn more, please do check out that VOD. Owen is fantastic. But if you're not familiar, Niantic Maps for Web is our real world 3D map. It's not a 2D map. There's actually like height that you can adjust here for building your own AR or 3D experiences with that like classic Niantic map look. You can adjust all sorts of different attributes such as the water, the buildings. You can change the colors. We have about, I think, 20 themes that you can use, or you can actually create your own theme to customize the map exactly like as you'd like. And if we go into the next slide, some of the components that we'll be talking about here, you can focus the map on a specific GPS point, like where you are right then, wherever your device is, or at a specific longitude, latitude. And a pop quiz for everybody here. Can you tell me where the GIF is focused specifically? Maybe you caught the country, but can you tell where that is? It's one of my favorite places to go. Also from the GIF, we can see the different zoom levels of the map are controlled by the radius. We can be as fine as almost like street level, or as you saw, the last one as far out as the country view there. Um, continent, maybe not that full, but yeah, oh, that's a lot. We also have an API that allows you to dynamically place content on locations worldwide. If you're familiar with our VPS product, you know that there are VPS activated locations all across the world. We have an API, a little check mark there that allows you to spawn objects on those locations specifically. So you don't need to make well, going on to the next point, you can also place anchor objects on these map points which are set at a specific longitude latitude. So if you wanted to make an experience that's at your park and I don't know, you have like 6 different map points around the park, you can do that. Or you can make experiences based off of the VPS activated locations that we have around the world. I looked at the chat. Is it Osaka? It's not Osaka, but you're really close. I'll just say that it's Tokyo Skytree. It's one of my favorite places to go. You can see on the first zoom level, I really love the building height feature that we have here. It really gives you kind of the scale of how tall Tokyo Skytree is. It's so cool. Anyway, no more nerding out. Next slide, please. What are we going to do today? First, we're going to learn how you add Niantic Maps for Web into Studio. It's extremely easy. But then the workshop would end too quickly, so we're going to add some more things to this. We'll talk about the simulator improvements that were made specifically for maps. We'll talk about customizing the map, kind of what are the themes, how you can add your map points, and creating map points and using the spawn locations API to actually place content on the map. All right. So if we go on to the next slide, well, next slide, we'll start building now. So I will take control of the screen. The first thing we're going to do is create a new empty project. I've already done that. So if you'd like to create an empty project right now while I get set up, this is a great time to do so. I need one more slide here. I can do this. Share. All right, quick screen check. How is that, Pablo? Maybe you can tell me.
Looks good.
All right, fantastic. All right, everybody. First thing we do is create an empty project. And then I'm telling you, it's so simple. Map has been added as a primitive. You click on the plus here for new object. The very last element here is map. And give it a hot second. And there it is. There is your Niantic Map for Web. That could technically be the end of this workshop, but we will keep going. let me show you, let me move this zoom window here. The map primitive itself is just like any other object. We can move it around. We have this little gizmo. We see its transforms. And if you focus on the inspector side here, we have those elements I was talking about using your GPS location or anchoring it to a specific latitude, longitude. This radius here is what controlled the zoom level, uh, as I was showing in the GIF, but I will go back to just, cool, let's do 500. And this section here, new map point, is how we can actually spawn the locations to, or not spawn locations, where you can actually anchor our 3D objects or experiences, whatever it might be, to a specific latitude, longitude. So we'll create a new map point. And what I want to focus on right here is notice the gizmo here is grayed out compared to, let's say, the box. This box we can manipulate as we'd like, but for the map point, these are locked because this transform is locked to a latitude, longitude. We can't actually edit the scale here. You could think of latitude, longitude, changing the position. We don't really need a rotation here, and the meters per unit would adjust the scale. So as you focus on the transform there, as I adjust this, the value of the scale changes. So if you wanted to actually, scale your objects or move your objects around, what you'll want to do is set your objects as a child of that map point. So I'll just take this box here, set it as a child, and as I move the latitude, longitude of my map point, all of the children of that map point will change as well. Let's see. I also want to note, let's move the box. Yeah, the box is doing fine. But if we change the latitude and longitude of the map itself, and we have that map point anchored to kind of behind the ferry building, if we change the latitude of the map and that anchor becomes out of view, it does disappear. Look at the hierarchy here. The map point is now hidden, but it's not gone. It's not deleted. If the user were to walk back towards that area, it'll spawn back into view. It's still anchored in that exact latitude, longitude, even if the user moves away from that map location. Next up, we'll talk about the simulator. Let me add one more map point to make this just a touch more interesting. This map point, oh gosh, Zoom is in my face. I'm gonna set this map point at a specific location. A nice little trick, you can go to your favorite mapping website, but you can also open up the geospatial browser to, let's say, I want to go to, excuse me, Coit Tower. That's how you spell Coit Tower, right? Yeah, I could do this, team. And you can actually get the latitude, longitude of locations right here in, excuse me, in Niantic Studio. So we don't have to go to somewhere else. Let me just set this. Coit Tower is about right there. 406 was it? There we go. And let me name it Coit Tower, just to make it a little more interesting. Boop. And so if we go to our map point there, around there is Coit Tower. You can have that shape, whatever that shape is. I don't know. Reset. And now let's build this. And we will be able to see in the simulator that we can actually focus our view on those different map points. Press play. Give it a moment. Where are we right now? I bet I forgot something. No, I think, where are we focused on right now? Oh, none. Sorry. The GPS focused on nothing right now. If I jump to Coit Tower, for example, here are the map points that I have in my project. This map point was focused on like behind the ferry building in San Francisco. While this one, we can jump to Coit Tower, and I just quickly threw a shape on it. But you can also change the latitude, longitude as if a user was actively changing their GPS in that moment. So you can walk more north that way. Let's head a bit east. You can dynamically change the latitude, longitude as if the user were walking in that direction, or you could jump specifically to a map point. Next slide here. next what we're going to do is kind of make the map look a little more visually pleasing. I mean, I love these map themes, but I don't love this skybox, this hard skybox that I see behind my map. So I'm going to add map fog to my project. So let me just close this for right now. If I apologize, I didn't show you the map themes. If you want to see more about the themes, Owen has a nice talk about it, but we could change our map themes, for example, to different ones here. You can change the different properties down here with select properties for buildings, for example. This is where, excuse me, I changed the building height where we can see better, we can better see the geography of San Francisco with the building height set to some value. But that is too dark for me. I want to go back to the one I had. Natural? Yeah, there we go. Excuse me. I think Pablo's passing on whatever he had to me. Sorry, Pablo, I don't mean to blame you. Let's see. Camera. The camera is just a little too high for me. I know that I want it to be a lot lower. I want to go to the ferry building-ish. That even might still be too high. I'll adjust it as I need to. First thing, in order to add some code for the map controller, excuse me, we need to add a new component file. Let's call this map controller dot TypeScript. Of course, because I'm doing a demo, this thing happened. It's happened to me once, and then I did this like 5 more times. It didn't happen, and now it happened right now. But a quick refresh, and we're good. At least I caught it on camera, and I'm gonna say, Owen, what happened here? Anyway, let me get some water. All right, ready to go. Demo gods are not going to curse me today. We've adjusted our camera. We have our new controller file here. What I'm going to do first is actually reference our instance of, or I want to be able to use 3.js in this project to control the fog. So you've probably seen this in our different samples if they use 3.js in them. We have our destructuring going on there, and then in add, so let me see if I can make this a little bit bigger. In add, here we go. What I'm going to do here is actually add fog. So this is going to run once our component is added into our scene here, which we're going to attach to our map. So very important, don't forget to attach your new components to objects in the hierarchy, or else it's not going to do anything. So how do we do this? World dot 3.scene dot fog is new. What I'm going to do is actually an exponential fog. The two types of fog that you can do in 3.js is exponential, where it gets denser kind of exponentially as you get further away, or linear. I just like this particular one. 3.fog, oh, fog exponential 2. If you wanted to learn more, Pablo can drop the link in chat, but you can also just Google 3JS fog. I am not good at colors, so I already wrote down this color. It's kind of like a light blue. And what else we're going to, let me scoot that over. We're going to change the skybox so that the skybox colors somewhat, somewhat match this color we've picked for the fog. So as I said, I'm not good with colors. I just wrote these down beforehand. Actually, George gave me these pretty colors, and I said, I'm not changing it. They're beautiful. Let's see. We've edited our skybox colors. The very important point that I said, do not forget to actually attach this thing. So we'll click on our map, click new component, and then under custom components, we have our map controller. So we should be able to build. And actually, great time to hydrate. And let's play this thing. So all we've done is added fog to our scene. Oh, where am I? Well, I have my fog. That's probably exactly where I said I am. What we're about to do next is actually add a player to the scene so we know what we're focusing our attention on. So next, we're going to be adding at map movement. I do want to make it clear here that for your projects that you're going to submit for this challenge, you probably do not want to rely on using the keyboard to move your player, your experience around. We want you to have these real world experiences. We want you to specifically rely on the GPS to move this person, this experience around. But as you are developing, as you're testing, you're not going to want to go outside and do all that all the time. So you'll probably want to use some WASD movement to uh, manipulate the map. So what we're going to do first is come back here to Studio, where get out of here. We'll click the plus. I'm just going to add a capsule to represent my player. I'm going to put it as a child of the map. And what you might not realize is that for the map, for our movement, as we hit WASD to move the map, we're not going to move this player. We're going to keep the player static. They're always going to be at the center of the map. They're going to be a touch smaller than that. But we're going to actually move the map around the player. So the player is going to always be our center point, and the map is going to change its latitude and longitude around the player. So we are going to go back to our map controller file here. Let me make it bigger. And then this code is not very interesting. It's not very studio specific. It's just kind of debug code. So I'm going to go a little bit quickly through this. Excuse me. Whew, we can do this, guys. So in the map controller within tick, this is code that's going to be run every frame. So every frame, we're going to listen to a key press. And if that key press is forward, backwards, left, or right, we're going to add or subtract to the longitude or latitude. So first step here, I'm just going to copy this that I have already, because if you want to watch me type it out, I'm definitely going to do a typo and embarrass myself. But typos are just a part of development. And sorry, I skipped over a little trick I do all the time. If your code looks it's not indented properly, it looks a little funky, oops, whatever it is, if you click on the double curly brackets up here at the top right, it will format the file for you. So if you see the little yellow warnings in Studio because your formatting is just a little bit off, don't worry about it. You can always click the brackets here to format it for you. So to go over what we have here, we have our 4 different variables representing the directions we want to move in. We are going to listen to the key press of W for forward, S for backwards, A for left, D for right. Not very interesting. We'll get into cooler map stuff soon, but for right now, thank you, Pablo. I already saw. I should just copy yours. It probably is nicer, not nicer. It's just for some reason mine are adding double spaces, so not sure why that's happening. Next, we're going to specify if the forward key is hit, we're gonna increase our latitude direction. Similarly, for backwards, we're gonna decrease it. It's just logic. This isn't very interesting. Thank you, Pablo. I think that's Pablo. My chat is so small, so I'm assuming that's Pablo pasting in the chat for us here.
Yep, got your back.
Thank you, Pablo. And then lastly, I missed something, didn't I? I'm just going to reference the component here. And then what we're going to do here is only apply movement if there's a change. So if latitude direction is 1 or -1, or if longitude direction is -1 or 1, then we'll do something. I will just reference my component here. So under the map.mutate, this is how you're going to actually want to change the latitude and longitude. You won't want to call like component.latitude or .longitude and change that. That will not be an accurate reference to the actual latitude longitude. So you'll want to use map.mutate to change the latitude and longitude in code. So what we're doing here is adding to the existing latitude or longitude. This is a helpful just conversion to conversion value to convert a latitude or longitude degree into meters. There's math online. This is just for debug. I don't want to get into into the math itself, but this is a very useful way to just use WASD to move around the map. So what we have after that is, all right, it's attached. It's under map controller. Let's build. And this is just a little too big. There's a lot of real estate I need here. So what we should be able to do, actually I forgot where the camera is pointing right now, but we'll figure that out. Oh, where? This is something I forgot. It's really important. If you want to change the latitude and longitude, you have to disable use GPS because every tick it's going to put me back onto the user's current GPS. So as I tried to move with WASD, I kept getting knocked back to my fake GPS location here because I had this enabled. So important to note, if for some reason your debug movement is not working, check if you had use GPS enabled. Let's go press play. Here I am. I bet my camera is out of view from the player, so I could fix that real quick. Where are you, camera? Oh, well, yeah, you're all the way over there. Silly me. Let's move you right there. If I wanted to specifically start at the ferry building, I'll just change my latitude a little bit. Yes. Don't forget to re-enable GPS once you're ready to submit this thing. If you look at one of our samples, it's very nice. George has it so that there is a flag on if you want to use WASD movement or not, because you can't have both of them on at the same time. So either debug controls or GPS, not the both of them. I won't build that for now. We'll come back to it. Next is adding locations. So, oh, I didn't notice that typo. Nobody noticed that typo, especially not Pablo. Don't judge me, Pablo. First, we're going to enable locations on the map. So go back to map, and then in the inspector here, we see spawn locations. We'll click the check mark here. And all this is doing is allowing Studio to create an event handler, or we need to create the event handler, but it'll create an event that will trigger whenever we see a map location, whenever we see a VPS activated location in our map radius that we have here. So first step, enable spawn locations. Next, we'll make a new file that will actually control the location spawning. So location spawner, call that. Uh, before I forget, I'm going to put this onto the map right now. So go to new component, custom components, location spawner. Not going to forget that later. Here we go, attached to the map. And now we're going to actually use a state machine to attach this to our state machine for our event handler. So these things here you see add, tick, remove. We're going to add another one for the state machine, and Pablo can share the skeleton code that we'll use for it that I'm going to directly copy so that you don't watch me just make more typos. It's part of development, I understand, but I don't want you to watch me make typos. So what we have here is our state machine. I really like these because it can do specific things for add or tick or remove depending on the state of that whatever your experience is. But for right now, what we're going to do is actually just add a listener for our event. So let me make this a little nicer to look at. So what we have here is our state's called default. It's going to be our first state that we enter. So that's why it has the dot initial there. Then what we're going to do is actually add a listener. So dot listen. It's going to be on this component. So this entity ID, the event is called location spawned. So the spawn locations event is called location spawned. Pretty straightforward. And then, whoops, once we have that event is triggered, all of that information about it is going to be in that event parameter there. Oops, that's too many. And then what we're actually going to do, we're not going to spawn anything right now. We're just going to print a console log. So console.log event.data. This is just going to print the data that the API will give us regarding the map locations. So let me close this up. I'm going to show you something with live sync real quick. So click live sync. You don't necessarily want to have live sync on as you're developing, but I want to show you how this API works. So I'll press play, hydrate, fantastic time to do so. Feels good. And play. And I had GPS off. Yeah, we're good. So if we look at the hierarchy here, we have these up to at least 91 entities. These are different map points that have been spawned because of the location API being enabled. So if we go to the console here, we can see all of these are different locations that we have found in our map radius. And for each one of these logs, there has been a entity, a map ID, or not map ID, a map point generated for it. So what we're going to do soon is for each one of these map points, we're going to add a child to it, and that child will be our 3D object. So you can see here the different things in the map point. If you're familiar with VPS, there's that hint image URL. We have the title of that location, and then its specific latitude, longitude values, and its map point entity ID. So let me close that for now. We have, let me see if I can show, for example, that entity 91 is in that location. And remember, for map points, you can't change the transform. You have to add a child to it, and then you can manipulate that child's transforms all you'd like. All right, for now, though, I'm going to disable live sync because it's going to give me issues while I'm streaming on Zoom. All right, next we're going to add the locations, or we already added locations. We're going to add objects to those locations. So one more file. It's only one more file to create, but it's going to be a big one. We'll add a new file. Let's go to location object.typescript. What we're going to do here is add some default values for our object. It's going to be pretty straightforward. As you see on the slides, we're just going to add a gray cube. Nothing very interesting, but this is the basis for your project. So in our add, I am definitely not looking at the chat, so thank you, Pablo. I just saw you're sharing all these steps. Appreciate you. We have in our ad, I'm going to copy paste this because I shouldn't be so afraid of typos, but I will be embarrassed if you see me like misspell component enough times. All right. So first, this is just an easy way to reference our entity ID so that we don't have to type component.entity, component.eid, component.eid. This should save us some time. The first thing we're going to do is set the scale of our box. Let me show you in the hierarchy. These are all things that you've seen before, you just maybe not have done it in code. But this line, ecs.scale.set, is exactly changing these values here, setting it to 0.25 x, y, and z. The position you also know as well. For in this world, this entity ID, whatever this location object is, set its Y to a position a little bit higher above the map. You're also familiar with this part here, the box geometry dot set. We're setting this box geometry component onto this object. So its shape is going to be a box. And then similarly for material, we're setting its material to be this just kind of gray color. But these are all things you've seen before in Studio, just maybe not in code. So what we're doing is setting this, setting the scale and position and adding a box geometry and material component onto this object. And if your code doesn't look pretty, just click these double brackets at the top, these double curly brackets, and it'll look nice. So we have added this information to our ad. Excuse me. Oh, thank you, Kyle. I just happened to look over. We're not good at spelling. We're not, well, some of us are good at art. We're not good at art. Our UI looks like boxes, but you know what? We get the job done. So next up, and that's why we have teams. We work on things together. This is a collaborative thing. What we're going to do next is actually enable this to be exported. So we're going to call this location object. It could just be object. Well, maybe don't say object. That's pretty vague. And then at the bottom, we want to make sure you export this so that we can actually reference it in, will this fix it for me? There we go. I don't need a comma. We can actually reference it in another file, which we will do right now. Next up, we want to go back to location spawner. And then we want to actually import said thing that we wrote. See, I already mistyped import. My fat fingers smashed two keys at once. Well, location object of don't worry about all that red. Once we finish typing, those errors will go away. It's just like, oh, hold on. I don't know what you're talking about. What's a location object? Let me cook and then you'll find out. So, all right, now we are done with our import. Next up, we want to, in the state machine, we're going to actually add a little bit more code here. You can delete the console if you want to. I like it. I'm keeping it. It doesn't matter. So we're going to make a location object, and this will be a new entity that we create. So world.createEntity. And next up, we want to set the parent of this object, that entity we just created. We want to set its parent as the map point so that we have the hierarchy that you see here uh, in the hierarchy. We have our map point, which will be the parent, and then our box is going to be the child. So we have our location object. We did that world dot set parent. So this will be our location object. Its parent is going to be in our event data. So event.data.map point. That map point is going to be the parent of our, excuse me, of our box, of our location object that we created. The location object dot set. We're going to actually set this component, our location object that we made right down here. We're going to set that component onto this instance that we just created. So world dot or just world location object. There we go. Don't worry about the error here. This map point warning is just saying that, hey, TypeScript doesn't know what a map point is. If that bothers you, you can add this little flag. Am I typing it wrong? At ts-ignore. Oh, it's mad because it wants a little space there. And that'll just ignore TypeScript specific errors. The code will run without it. I'll prove to you that the code will run without it. Are we missing anything? I don't believe so. So we will build and hydrate. And once that is, did I attach it? No, it's already attached. We're good. We're good. I didn't forget to attach anything. Click play. Let me close this so we have some more space though. And there are all of our map points. So the map points were already there, as we remember from these console logs. We know that they're there, but now we have a visual representation on top of them. And then from here, we're close. We're close to finishing this workshop. Thank you all for following along. Now we're going to get into even more code that I will inevitably have a typo on, but we're going to get through this together. So next up, what we're going to do is you see in the GIF here, as we get closer to these location objects, we want them to do something. The something in this case is just going to be change your color and animate. Not that interesting. But what we want to be able to do is define what is close enough. So what we're going to do is actually define a threshold schema just to signify what is close enough. So let's go back to location spawner. Let me open it up here. And then in the schema right here, we're going to add just one little variable for, or parameter for threshold. This is going to be a float. Okay, there we go. And whenever you have something in the schema, it's just best practices to set a default value for it. Uh, you know, you don't have to, but if you end up seeing weird things happening in your code and you didn't do that, I will tell you, hey, did you set default for it first? Well, do that. And then let's see if you still have that problem. Next up, we're gonna edit just a little bit of things right here. So we want to actually pass this threshold value onto our location object. So we're going to add, I don't want to keep doing typos, so I'm gonna actually copy this from my notes here. So we are going to want to reference our threshold. So from schema attribute.get for this component ID, we'll reference our threshold. And then under this code here that we already have, location object.set, we have the world, the location object that we're adding things to. And then we're actually going to pass on the threshold that we have here. So now when we create a location object, we're going to actually pass the threshold value, which we will I'll show you in map. We scroll down here, we see that threshold is equal to 1 because that's what our default is. Let's go to the location object because we're passing on this threshold, but we're not doing anything with it yet. So this is where it's going to get a little gnarly, there's just a lot of things that we need to add. I will try to explain them, but not take up too much time because I just look at the clock. We're almost there, team.
Here we go. One quick question from David
Yeah.
is the 1 equal to 1 meter, or is it another measurement? And this is regarding your
Mm, the threshold. It's equal to 1 from the way I understand it. Can I make you smaller? 1 world unit. So if you whoa, if you look at each one of these squares on the map, uh, it's um what is the right word? Size is not size, it's like sides are it's composed of 1 world unit. So if you want it's hard to say that it's 1 meter because the radius of your map is going to be could be different. I'm not familiar with how it'll scale. If like your radius is 5,000 or 50,000, it's still going to be one of these square units that you see on the map. If I am completely wrong, George will probably clarify in the chat, but it's not meters, it's a world unit there. Um, Great question though. I appreciate that. I'm sure everybody's gonna learn something from that. Uh, I might have gotten a little lost. All right, location object. Here we go. Let me open it back up. We want to actually reference the threshold here. So just like we saw in the previous example, we will do threshold ECS.F32 really quickly. I might speed through a little bit of this. So we define the threshold schema there. We are actually going to create a state machine, just like we did before. And this is going to be where the state machine really shines because we're going to have 2 states. We have our default state where nothing has happened. We've not had any visitors, and our visited state where we will change our color. We'll add our animation. So this is where the state machine is going to be a lot more powerful than just simply we could add all of this into tick and have, one big if else statement, or we can use a state machine to handle this for us. So what I'm going to do is add here my little state machine, my state machine skeleton code. I don't need to do that, but let me quickly talk about what we have here in our state machine. So just like before, we have our default state. It's going to be the first state we go to. And then on enter, once we get into this state, this is actually where we're going to, I'm going to copy paste the code that we have from add and put that into on enter. So when we enter into this state, set our geometry, set our color, set our position, set our scale. And on tick is where we're going to actually listen for if we've met our requirements to be within the threshold of our between ourselves and our object. And then if we're in the visited state, that's when our on enter will be change our color and add an animation. I will, in the interest of time, kind of go through this a little quickly. So we will just copy all of these elements here from our add and put that into our on enter for our default state. Clean that up a little bit. And then we will add some code into our on tick here. Ooh, on tick, let me copy the notes that Pablo has because it has some beautiful comments. And if I don't talk about everything, I will at least have these comments here for you. So we get a reference to our threshold, and we're going to do some math, the Pythagorean theorem, to understand the distance between ourselves and that map point. So what our math here is doing, like fun little comments. What our thing here is doing is calculating the distance between our parent, which is the map point, and ourselves, which is the center. Remember, we're never ever moving the player. They're always at the center. So we're just calculating the distance between us and the map point. And if that distance falls within our threshold, do something. Our something will be go to the visited state. And so now what is the visited state? We're going to very simply define that. It's let me just copy this really quickly. Oops. Oh my gosh. I can't spell, I can't highlight. You know what? We're gonna get through this together. We're almost there. I definitely want you to have time for Q&A. So let me really quickly go over. I don't even know what color this is. It seems like it might be pink. Change the color of the material and add a rotate animation. Once again, it's something you've seen. If I go to new component, animation, rotate animation, these values correspond one-to-one to what you see in the rotate animation component there. But I'll remove that for right now. And then lastly, we've defined our states. We've defined our default state. It has an on tick, just like the normal tick. How do we actually go to the next state? We have 3 more lines of code. We are almost there. The first thing we want to do is define a trigger for the state. So we'll add it for the first thing here. Visit trigger is going to be defined as so. Defined trigger. Thank you all for your patience as I ever so slowly type in either the right or the wrong thing. Next up, we need to add a section here under the default state for it to do something when it sees a trigger. So on trigger, this is under the default state. It will go to visit. On the trigger visit, go to the state visited. So this will listen out for that trigger. If it sees this trigger fire, the state machine will switch to the visited state down here. And then how do we do so? Right here. So if our distance is within the threshold value, we will go to the visited state. So visit.trigger, just that's it. Do it. Let's see if this will build and play. Oh, hydrate time. Always hydrate. Ah, and now there we go. I think I had it set to 1 world unit, and as I get closer, and that's like I don't know, magenta, not pink. But as I get closer to these objects, they are starting to highlight. When I come back to them, they're still highlighted. Let me see if I go like completely, I'm kind of using up your precious time. All right, but just want you to see that they're still in that state. Oh, Or did I mess it up? It's okay. It's okay. We're at the end of the workshop. We achieved what we wanted to achieve. If you want to add to this, please. Oh, spaces. Pablo, I'm so sorry. Everyone, I'm so sorry. There's one more thing I needed to show you. I will stop messing around with this thing. Running low on time really quickly. Spaces. Maybe we'll just look at the slides here. So spaces are essentially, if you're familiar with scenes in Unity, these are different scenes to enable modular uh, hierarchy management, let's say. So the objects in your hierarchy here are very specific to that space. So let's say you wanted to have another mapping experience that had a completely different map look, had completely different map points, whatever it might be. You can just create a new space, call that, I don't know, MySpace. I'm sorry. I'll call it MySpace, and this can have a completely different map. It can even be an AR experience. It can be whatever it is you'd like it to be. All of those changes that you make in that space are going to be local to that space. There's more to spaces. I'm just showing you something you can do with it and maps. You can go back to this space. We have our old project there. It is all A-OK. Definitely learn more at our in our documentation on how you can actually change spaces into code, how you can share specific objects across spaces. There's more in our documentation there. Whew, okay, wrapping up. What we've learned Jamaica can't spell. We've learned how to add Niantic Maps for Web into Studio, super easy, literally one click. We learned about some simulator improvements for Niantic Studio. We've learned how to customize the map either with our debug movement, with map points, with map themes, how to create map points, and how to use the spawn locations API to actually place objects on known locations in the Niantic space. Next steps, improve this experience. You can, let's say, for example, go to the different nodes and collect points as you visit them. Make a resource collecting game. When you go to parks, you get wood. When you go to water, you get water. We do have two great examples on our website for combining DPS and maps together, and we also have a scavenger hunt. These were both made by George. He is fantastic. This workshop is essentially a modified version of one of those. So if you wanted a like ready to go final project, just check out the scavenger hunt sample and you will see similar things, not similar things. Okay, time for Q&A. Thank you, everybody. Thank you for going on this journey with me. I hope you learned something about maps.
Yeah, we also learned that Jamaica is a total badass. So thank you for an amazing workshop. We have some time now. We have 5 minutes for Q&A. I'm going to speed run through some of these because we did answer them along the way. So David in the comment section just asked, is a space analogous with Unity scenes or closer to prefabs? It's essentially just scenes, like you described. And then Tristan asked, can you add an animated avatar that moves along the map when you move? And I'm assuming you mean using GPS. As Jamaica mentioned, the scavenger hunt sample project is available in our project library. You can go to eighthwall.com/projects. And in that sample project, once you clone it, you'll see a character Dodie walking around in the map. So you can kind of copy and clone that and add your own 3D character. Just make sure that the 3D character has a walking animation built in before you bring it into Studio, because you can't add that in Studio. And then Tristan asked, this might be for George and Jamaica. I don't know if George is still here. Doesn't look like it. Is it possible to combine the Scaniverse locations with the map so that when I arrive at one of those locations, the AR feature will run? So this is essentially asking VPS. Does it work with Niantic Maps and Niantic Studio? And the answer is yes. As mentioned, the two sample projects will walk you through that. In this case, Studio Map Explorer might be like a good place to start for you so that you can see that in real time and working as expected. And then David Wilson had two questions. One is really long, Jamaica, so I'll read it as quickly as possible, but you might want to read it as well. Are there any Niantic slash eighth wall integrations or hooks for ArcGIS or general GIS data? Wanting to integrate the global standard for non-entertainment geospatial data into the accessibility of Niantic's UX and accessible deployment.
I must admit I'm not familiar with ArcGIS, so I don't fully know how to answer that question, but something that might help. I don't know if this ArcGIS GIS can be formatted like JSON or CSV, but if you're able to just get the latitude and longitude information of it, you can always write a script in Studio that they'll then process JSON or CSV and create those map points dynamically. I don't know if that's going to satisfy your requirements, but if you have that data, you can make a map point out of it. So if that helps, that could work. But as it is, I don't believe we have such hooks because I'm not familiar with ArcGIS. I apologize there.
Yeah, thank you. And this is a question we get often from David Wilson. Is there a roadmap to make the state machines visual blocks instead of code script? Not right now, but that is a great suggestion. And as you all have these suggestions, please don't hesitate to also post them in the forum, eighthwall.com/forum. Our support engineers and our development engineers are looking at those suggestions and taking that feedback to improve Niantic Studio. So please continue to harp on that as much as possible. All right, next question. Adriana asked in the comments, if I were to execute this in the real world using my phone, would I see the objects superposed on the camera view or the full virtual map on location? So I think I'm understanding this question, but essentially what you will see out in the real world is what Jamika was showing you in the simulator. Um, so until you actually arrive at a location, then you can create an action to open it, in which case your camera will be activated so that you can localize to that location, and then any AR elements that you add to that location will then begin. But the map that you will see out in the real world is exactly what you're seeing in the simulator, as Jamika was showing.
Right. It sounds like you probably would like a VPS experience where when you make it to that location and then you switch to AR view, you could see your cube, your character, your whatever it might be. But those are two different views. One is just the camera onto the world map, and another is the camera into the like your front face, your back facing camera. There we go.
Got it. And last question from Kyle, will we get an AR training version of Map soon? I mean, world view version. I don't understand that question. Do you? Oh, do you want to
I,
unmute?
Sorry. So right now, what we're seeing with the maps is the digital view. But what I want is, as I walk down the street, I want to be able to see just like my bullet, the points over locations, not within a VPS yet, but just, as I'm walking to see little, coins circling above the locations.
mm, As it stands, I'm not sure. I feel like it's possible, but I've not tried it, where you can have essentially the map is like a plane in your AR view, and as you walk, I don't, I might want to test that out first. I might have to follow up on that if it'll work.
Yeah, like worldviews. So when I'm looking at
Yeah,
it, it's essentially AR. So it's an overlay to what I'm seeing through my camera. It's not just like filling the whole screen with a graphic map.
right. I just at this moment right now, I just don't know if that will work as expected. So I will have to follow up to make sure that that is something that either it does work, or if it doesn't work right now, what are our blockers to getting it to work?